Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to all viewers. My name is Sherry, the moderator for today's session. Welcome to all viewers to the 9th series of Research and Innovation webinar, School of Electrical Engineering. This program is brought to you live from School of Electrical Engineering, Faculty of Engineering, University Technology Malaysia's Johor Bahru's Facebook. Without further ado, I would like to invite Professor Dr. Muhammad Kamal Ibrahim, the Associate Chair of Research and Academic Staff, to give a short opening, as well as introduce our guest speaker, Professor Dr. Zaharuddin Mohammed, the Head of Advanced Control Research Group. Over to you, Prof.
Thank you very much, Puan Sherry Huzaima. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And salam sejahtera to all viewers. Once again, thank you to all viewers who are watching live on our webinar series number 9, brought to you by School of Electrical Engineering, Faculty of Engineering, University of Malaysia, Johor Bahru. I'm Professor Muhammad Kamal Ibrahim, Associate Chair, Research and Innovation, School of Electrical Engineering, University of Malaysia. Today, we are going to have talk from Professor Dr. Zaharuddin bin Muhammad, the head of the Advanced Control Research Group. Before he gives his presentation today, I would like to read about his biodata. Professor Zaharuddin Muhammad received a Bachelor Engineering in Electrical and Electronic Engineering from University Kebangsaan Malaysia in 1993, Master of Science and PhD in Control System Engineering from the University of Sheffield, United Kingdom in 1995 and 2003 respectively. He is currently a professor and head of Advanced Control Research Group at the School of Electrical Engineering, University of Malaysia. His research interests include vibration control and control of Mechatronics system. He is an issue editor for the Measurements and Control System, Control Journals, and served as editorial board members in several journals. Today, he will give a presentation on a current research in control and mechatronics. Please share. I hope that you can share, like, and comment at our School of Electrical Engineering Facebook. Now, I would like to invite Professor Zaharuddin to give his talk. Over to you, Prof.
Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all. Thank you very much to Professor Dr. Kamal Abdul Rahim, Associate Chair for the School of Electrical Engineering, for the introduction. I am representing the Advanced Control Research Group. Will be sharing with you some research involving the research group in control and mechatronics. The research, the presentation will mainly cover current research conducted at the research group. And we have two objectives here, is to share the current research conducted at the research group and to encourage future research collaboration. We hope from this presentation, the objective can be achieved, and it is hoped that at the end of the presentation, we could establish future research collaboration with researchers, local researchers, as well as the international researchers. We have 16 members within the group, which comprised of 2 professors, 5 associate professors, and 9 senior lecturers, all with PhDs with various expertise within control and mechatronic engineering. And the tak boleh. Okay, sorry for the mistake. For the technical errors, actually we have two objectives, as I mentioned just now. The objective is to share current research conducted within the groups and to encourage future research collaboration with the research group. And we have 16 members. The research group, the research area conducted within the research group can be divided into four, which are Mechatronics, Robotic and Autonomous Systems, Control and Automation in Agriculture, and also CyberPhysical System. I will share with you each project within the research focus briefly, so that if you need further information, you can contact the research group. Let's go into the first one, which is Mechatronic. In the mechatronic area, it involved mainly in modeling, simulation, controller design, and also real-time implementation on various mechatronic systems. The system that we are considering at the moment is flexible dynamic systems, automotive, and also high-speed train. We also focuses on water and wastewater treatment control and some application of nonlinear control on dynamic system. Okay, let's move into the first one, which is the control of flexible dynamic system. The system is ranging from nanoscale to industrial crane. So the system that we meant by flexible dynamic system is the system which is under-actuated. Under-actuated meaning that they have a lower number of input as compared to the degree of freedom. Therefore, not all outputs can be controlled directly. And the problem with this system, they suffer from significant deflection, vibration, and oscillation during their motion. Some of the examples are piezoelectric nano positioning systems, CNC machine as shown in the picture in the PowerPoint, and industrial tower crane. So those are considered as flexible dynamic system, and this demonstration, which is a drone with a cable suspended load, will try to show you the problem with the flexible dynamic system. This is a video showing a drone carrying a cable suspended load and is used for transportation system as an aerial transportation system. But in motion, in flying, you can see that it moves with a significant load oscillation, which will be difficult to control, and it is dangerous to human, to environment, and may also make the system very unstable and may also pull down the quad rotor. So the aim here is to control the drone to move to a desired point with low oscillation. So this is another video showing what happened when we control. What happened without controller and with controller. This is a lab scale double pendulum overhead crane, and this is a load, a hook and a load. When it moves to a certain position, it moves with a significant vibration. And it sways for a long time before it can settle down. With a controller, we can make it faster, as fast as the one without controller, but with no oscillation. So the aim here is fulfilled by using a controller that can reduce or suppress the oscillation. There are many more opportunities in for further research in this area. Many cranes, such as tower crane, boom crane, also including crane in underwater, can be studied. We can also study many type of payload, many shape of payloads. Every shape has different dynamics. We can also study the one with wind disturbance. As we know, in open space, wind disturbance will disturb the performance of the system. So it will be very difficult to control with wind. We can also apply the controller on various vibrational systems. The one shown here is a two-link flexible manipulator. And we can also apply a controller to control the drone with a swing load, as I mentioned in the video just now. So this is the first area, which is the first project in Mechatronics investigated under the research group. The second one, involving automotive. This is the project regarding active suspension and active steering control. These are the controller are designed to provide comfort and safety to passenger during motion. This is difficult. The control design is difficult, as many parameters need to be considered. Many road conditions, disturbance has to be taken care while designing the controller. At the moment, in order to verify the dynamic models and also to verify the controller design, within the research group, we have two test beds. First, to test active suspension control, and secondly, to test active steering control. And currently, a team here is developing a robust controller in order to design active suspension and active control system. Similarly, in the same area, we have also a team studying control of high-speed tilting train. This is a special train where it can tilt its body when moved into a rail track curve. By tilting its body, it can improve speed, and will be similar as the speed will be similar as the one on the straight track. Okay? So one of the major benefit of using high-speed tilting train, it can be used on the existing rail track. No need for a new track. So this will be a huge cost saving. So this is actually a government-funded grant. The project involved development of an event controller for this kind of train. And of course, as Malaysia will be having many high-speed train, this will be very useful in future in order to improve the existing high-speed train. The next project in Mechatronics is process automation for water treatment and also for water treatment and wastewater treatment. The one shown here is a pilot plant on surface water membrane purification system, where we mainly apply artificial intelligence to model the system based on data-driven model, and also we try to monitor and also control the process automation. Okay? So the pilot plant is used for modeling and also to verify the design controller. Current research involve improving energy efficiency and to develop model-based energy optimization techniques, to develop a data-driven model based on AI, and also to develop advanced controller to improve the system, the monitoring of the system, and to improve the performance of the water treatment system. In the same area, we also attempt to automate a wastewater treatment system. The one shown here is a pilot plant with membrane bioreactor, and shown also the monitoring based on data taken from the pilot plant. And currently, we managed to design an MPC controller, model predictive controller, to improve the system performance. And this is based on a new optimization cost. We designed MPC with a new optimization cost, which result in a better system performance. And ongoing research on this is to further improve the system with a low energy process automation. So the one who is interested on this can contact us for further information on process automation or water and wastewater treatment system. Besides, we also apply nonlinear controllers to many dynamic systems. We apply on flexible dynamic system, we apply on automotive, on train. We also apply on power electronics. The one shown here is an example where we apply model predictive control on induction motor drive. And also we apply sliding mode control for inverter control. So these are two examples where we apply on power electronics, which will be used for many applications. Next, we move to the second research focus, which is robotic and autonomous system, which is very important in the era of fourth industrial revolution. There are 5 projects here. First is control a mobile robot with SLAM simultaneous localization and mapping, machine vision, control of drone, underwater robot, and also wall climbing robot. So we have 5 projects to be showcased during this presentation under this research focus. The first one is mobile robot. Of course, we know that mobile robot is used in various applications, but still this is an ongoing research, still an active research, because to obtain precise robot positioning is very challenging, especially under various constraints, with disturbance, with noise, with different loads. and also sometimes error in the sensor signals. So it's very difficult, still and it's active research, and we develop many controllers, linear and nonlinears, in order to improve and to improve the tracking of mobile robots. Similarly, a mobile robot will be more useful if it can be embedded with SLAM, simultaneous localization and mapping. And here we attempt to use LiDAR sensor. This is a 2D LiDAR sensor and a camera in order to improve the accuracy of mapping and localization. We know that LiDAR is light detection and ranging. Sensor is very expensive. 3D LiDAR sensor is very expensive. And here we attempt to use only 2D combined with a camera in order to significantly reduce the cost in order to get a SLAM system. So based on the two sensors, the laser sensors and camera, both information will be combined in order to obtain and improve the accuracy of mapping and localization. And the most important thing, with a lower cost. Let's see a demonstration on the one that we have developed so far. This is a robot with a LiDAR sensor, with a 2D LiDAR sensor. It managed to create a map used for to move, and of course it can avoid obstacles. This is the first person view viewed by the robot, and here is a third person view viewed by human at the workstation. The good thing it can create map, and in the next phase we will combine the laser-based data with camera in order to further improve the mapping and the localization. Okay, the next project in robotic and autonomous system related to machine vision. Machine vision, as you know, is very important, especially in robotic and autonomous system, for detection, for recognition, and also for navigation. Okay, the project mainly involved development of an accurate machine vision algorithm. So many algorithms available in the market, but we intend to improve the existing algorithms. And here we would like to showcase three projects which we use machine vision. The first one is UAV or drone equipped with vision-based navigation system. So the machine vision is used to detect the area of interest to perform a desired task. So if we manage to obtain an accurate algorithm, that will be good in order to efficiently complete the task. Second project that we use machine vision is we have developed an unmanned surface vehicle in order to collect waste at a river. So the machine vision is used to detect and estimate the coordinate of the polluted area, and then move to the area and do the collection. The third project using machine vision is involving natural user interface for human-robot interaction. So in this case, we use hand gesture in order to give command to the robot to do certain things. Different gesture will have the robot with different gesture. The robot should be able to do different tasks as programmed. So in this case, in all the cases, of course, accurate algorithm will be very important. So there are more research opportunities in machine vision and can be applied to many other applications. We also design a controller to control drones in the research focus of robotic and autonomous. We know that drone is currently used in many applications. It is estimated that drone will be widely used in industry, especially in smart warehouses. But control of drone is very difficult as they are under actuated. There are only 4 input, but many more outputs to be controlled. And drones are affected by, of course, wind in open space. And if drone carry different load, it has different dynamics, which is difficult to control. And the design objective here is to move the drone to the desired point under unknown uncertainties and also disturbance. The one shown here is the one that we have developed. We control drone by using MATLAB. This is a simulating block diagram, and the connection is through Wi-Fi. We managed to control the drone as shown here. This is a demo showing 2 control tasks, which is drone hovering and also point-to-point control. First one, we managed to, for drone hovering, we control altitude and also attitude as what we desired. It stopped at the desired point, and we managed also to move point to point from A to B to C to D. So based on using the controllers. So this is controlled by using by MATLAB, by using a simulating MATLAB. The next project in robotic and autonomous system is the development of underwater robot for water tank cleaning. It is the requirement of the government for the water tank to be cleaned every 6 months. So in order to do that, manual cleaning will have some effect. Many issues with the manual cleaning. First one, it may have to interrupt the water supply. If we send people to clean the water tank, we need to sometimes stop the water supply. We also need to send a professional divers to do the cleaning, but this brings safety issues and also hygiene. And without a proper cleaning, we will not get a clean water. Okay, the last picture shown here is the water taken out from one of the water tank. So many issues with manual cleaning. One of the solution is to design an underwater robot to do the cleaning. So this is the one that has been developed within the group, and the first two shown a few site testing to clean water tank, and the robot is connected to a ground workstation equipped with a camera and other sensors for real-time monitoring. This is the output from the underwater robot cleaning. We can see the upper picture. This is the before cleaning, and the one beside is after cleaning. You can clean the water tank, and the bottom one is the robot in operation. And the good thing about the system, it can also provide a mapping showing where the robot goes in the water tank, which part has been cleaned, which part not yet cleaned, so that it can be used for future reference, for future work. Okay. Also from this, past planning research can also arise from this in order to get precise and optimum cleaning route. The last project in robotic and autonomous system is development of wall climbing robot for building inspection. It is again a requirement from the government for the building to be checked regularly. So the one of the technique to do this is by using a wall climbing robot, which can navigate on a civil structure and do inspection of the building condition. The robot research, of course, involve robot design and development. The one shown at the bottom is the robot that we have designed and also that we have developed. The design robot has been tested. The one at the top showing images of crack detection, which is sent to the workstation to be analyzed. And also the robot is able to provide localization and mapping. So this is the current project on current status on wall climbing robot. And of course, the research involve further research involve improvement of the robot design, adhesion mechanism. We also want to have online and offline image processing for crack detection. We need to improve the accuracy of the algorithm, and we need to improve also simultaneous localization and mapping capabilities of the robot. So these are 5 projects within robotic and autonomous systems. The third focus is on agriculture. Agriculture, as we know, is important for our country. If we can have a proper control and proper automation, research agriculture activities will be improved, will be enhanced, and a more quality product can be produced. So here we would like to share 3 projects in agriculture. The first one is Capillary Irrigation Management System, autonomous robot, and also machine vision. The first one is Capillary Irrigation Management System. This is actually an improved irrigation management system which attempt to do water saving. From the picture here, you can see that actually the plant, the circle one is the area which water should be, is the wetting zone. Okay, the water outside the circle will be evaporated. So if we can manage to only supply water in this zone, and according to the plant water demand, we can significantly save water. Okay? So this has been tested, and the water is supplied to the plant through what we call capillary. So this is another invention where we use a capillary to supply the water to the plant. And this has been tested on a real tomato plant with the water, this is the water plant, and capillary is used to supply the water. We managed to significantly save water and provide a good quality tomato. And imagine in a huge plantation, significant water saving can be obtained. Second project, which is actually an advance of the previous one, now we further improve by supplying the water based on the weather and also the soil moisture. Based on these 2 sensors, 2 data, we supply the water again through capillary, and it has been tested on a rock melon, and has produced a good rock melon and with a good water saving. Many more research in this area can be explored on different plants also. We also apply autonomous robot on agriculture in order to improve some process. In this, we use robot for inspection to detect an unhealthy plant. This is a robot in a greenhouse with rock melon plant, and it has been tested. Now, still on an ongoing research involve a control algorithm. We need to design a good robot mechanism. We need to have good path planning in order to have a shortest route of the robot. And we can use also machine vision for detection. This is an example where we apply path planning in order to get the shortest path of the robot. The one shown here is a virtual environment of a greenhouse with a rock melon. We use, in this case, at the moment, we use genetic algorithm to generate the shortest path with a minimum routing angle. We managed to obtain the best route with the lowest routing angle. And of course, there are many other algorithms which can be studied in order to improve the path planning. Similarly, we also have machine vision. We also use machine vision in agriculture. The one shown here is a robot, is an autonomous robot equipped with a camera for machine vision, mainly to detect plant growth and also to check the condition of the plant. It can also be used to check the growth of fruit, in this case, the growth of rock melon. Again, this is still an ongoing research. We need to improve the algorithm in order to get the best images and also the best detection. If we can manage to always monitor the growth of the plant, the health condition of the plant, we can do interfere. We can do some inspection and do some spraying to the plant. Okay, that is the third one. We move into the last research focus, which is in CyberPhysical System. In here, we will showcase 4 projects. The first one is Network Multi-Agent System, Event-Based Feedback Control, Quad Rotor or Drone Formation Control, and also the last one is Predictive Maintenance. CyberPhysical System is currently very important, especially during the era of fourth industrial revolution. CyberPhysical System consists of 2 layers. The first layer is cyber system, where the system stores data, stores controllers, these may be computer, cloud, or so on. The second layer is the physical system, which is the system that we want to control. Can be drone, can be machine, can be robot, can be anything, which is the one that we want to control. The problem here is they are not directly connected. They are not directly connected. They connected through wireless. So the problem here is we want to control the system wirelessly. And based on sensor data from a physical system, a controller in the cloud, in the cyber system, will do computation and send a command signal to control the physical system. The issues in this problem, in this CPS, cyber physical system, beside controller issues that has been discussed before, like disturbance, parameter uncertainties, in this cyber physical system, the problem also include communication parameters, such as time delays, packet losses, we need to determine the best sampling frequency and so on. And this research mainly involve network control and also time delay control system. The first project that we have in CyberPhysical System is the network multi-agent system. This is a system that consists of many autonomous systems we call agent. They are cooperating together to perform some difficult tasks. So the photos here show a multi-robot system. Many robots, they have to work together in a production line to perform a task. The second photos is on the intelligent and autonomous transportation, where all the vehicles, all the systems are connected. They are all agents, they are connected. They should be cooperating together to have a smooth transportation system. In order to study this network multi-agent system, a team within the research group has developed a test bed for water level control test bed, with 4 water tanks and 4 controllers. They are the task is to achieve a desired water level, maybe different desired water level at different tank, but they should be cooperating together. Okay? Based on many CPS constraints, as we mentioned just now, regarding time delay and so on. In order to obtain the desired performance, several network topologies can be studied. The one shown at the bottom here are 2 network topologies that are currently explored, and many more can be explored in order to find the best optimum performance to control the 4 water tank level, which is considered as 4 agents. The next project in CPS is event-based feedback control. The problem with CPS, there are 2 objectives as compared to the normal control system. We also need to have a good computational performance at the cyber layer. In addition to the controller performance at the physical layer, we also want to improve the performance at the cyber layer. So the normal controller is normally the controller is updated based on sampling time. At each sampling time, the controller gain will be calculated and updated. This will be very burden to the performance at the cyber layer. So we propose an event-based feedback control where the controller is calculated and updated based on triggered event. When it triggered, then we calculate again. So the event is determined by the users. We have studied this and showed that it can significantly improve or reduce the control computation. This is the result where we applied on a simple spring mesh damper. We studied set point tracking and also disturbance rejection. You can see that the red one is the one that we proposed. The result is comparable or better than the existing technique. And the best thing at the bottom, the one that we propose has less computational time. So less computation means a better performance at the cyber layer. The next project in CyberPhysical System is multiple drone or quad rotors formation system. If we have many drones, in order for them to do tasks efficiently, they must be in a desired pattern. they always must be in a desired pattern. Okay? So for example, for search and rescue mission, maybe we always want them to be in a straight line. For coordinated surveillance, maybe in certain formation so that it can cover many areas. The last example, maybe in order for them to carry heavy objects, so they must be in a certain formation. So the task here, there are two tasks here. First is for them, for all the quad rotor, all the drone to move following a desired trajectory, and the second one is for them to maintain a desired pattern. So two control objective, and of course many disturbance, mainly wind, the parameter uncertainties, they are under actuated, and of course with CPS, many CPS communication problems. These are simulation results that we have obtained using graph theory methods. Initially, there are 5 quad rotors here. Initially, they are at different location, different height, different heading, but with the algorithm that we apply, within 10 seconds, they can move to the desired pattern, which is in this case a square pattern. And the two graphs beside here showing that they are at the same height, same height, and also same heading. So within 10 seconds, we managed to control the quad rotor to be at the same desired formation and the same level, same height, and also same heading. Okay. Of course, this is a simulation result. Further work on experimental result on real-time implementation will be very interesting, will be challenging, will be very interesting, in addition with many disturbances and also other constraints. The last one, what we want to show here is under CyberPhysical System is predictive maintenance. In industry, there are 3 types of maintenance. The first one is run to failure. That means we run the machine until it fails. It also called corrective maintenance. So when it fails, a service engineer will come to fix it or replace with a new one. So this is the first one. The second one is called preventive maintenance. This is widely used currently when maintenance is performed in a schedule, in a planned schedule, normally determined by the supplier. And the last one, which is new, current actively researched, is predictive maintenance, where the condition of machine is continuously monitored, and the condition is predicted. So it can save costs or save on we can have a saving on service costs as well as to avoid machine failure. How to do that? With cyber system and powerful computing algorithms, we can have advanced sensors attached to the machine. We can have many data. We can have big data, and we can use many algorithms in order to determine the condition. One of the technique is using AI. Then machine condition can be monitored, can be predicted, and administration will be alerted to do the maintenance. Okay, these are the project that the last project in CyberPhysical Systems. We have shown you 4 research areas with several projects. These are selected journal publication published in 2020 in journals just to show you that these are good. The research can be published in a good journals. These are in Mechatronics. These are in agriculture, in formation control, drone formation control, in UAV control. And in conclusion, we have shown you several projects under 4 categories. And finally, the research group welcome for research collaboration. And also we welcome research students to join the research team to further improve the design and further improve the algorithms. For further information, you can contact me and I will link up you with the respective researchers for further discussion and collaboration. Thank you very much for joining the webinar.
Okay, thank you very much, Prof. Zaharuddin bin Mohammed, for giving us a very informative talk on control mechatronics and robotics. Now, I would like to open for any Q&A session. Please post the question in the comment of your Facebook Live. Okay, if there is questions, so you can post now. Maybe before I have some question. Why robotics becomes so advanced to the recent years? Prof. Can you just answer the questions?
Thank you, Prof. Kamal, for the very good question. Yes, as we are aware, robotics are becoming very advanced in these recent years. It's used in many applications in industry as well as in domestic application. Of course, there are many factors that make robotics so advanced in these recent years. One of those is falling in, as we know, sensor price are falling. Okay, as I mentioned just now, we use LiDAR, 3D LiDAR, 2D LiDAR sensors for mapping. Previously, sensors are very expensive, but currently with the advanced sensors, advanced technology, sensors are becoming cheaper and affordable. So that make robot more advanced, and many people can have the chance to develop the robots. Secondly, perhaps with the open source development algorithm such as ROS, Robot Operating System, which significantly help researchers to develop algorithm to control robots. These two main factors in make the robot more advanced. Thank you.
Thank you. All right. Okay. Another questions maybe. How research in control engineering related to industrial revolution 4? Maybe can you relate with the industrial revolution on the control system, on the research in control engineering?
So in we know that in the fourth industrial revolution there are many focus area. There are 9 focus area. A few of them are very much related to control and mechatronics. For example, one of those areas is robotics, autonomous robots, which I mentioned just now, I described just now. So they are very important and very much related to our research. Beside that, we have also simulation. Simulation also focus in IR 4.0. In control and mechatronics, we extensively use simulation to test before real-time implementation. Beside, in IR 4.0, we have another research another focus which is big data, IoT, these are related to cyber physical system that I mentioned just now. Thank you.
All right. Okay. I think, yeah, we don't have any more questions. Thank you once again to Professor Zaharuddin Muhammad and all to the viewers that took part in this particular webinar series. Now, I would like to pass over to Puan Sherry for the closing remarks. Over to you, Puan Sherry Huzaima.
Thank you, Prof. Kamal. And thank you also to our guest speaker, Professor Dr. Zaharuddin Muhammad, for the interesting topic just now. Thank you, Prof. All right, viewers, we are at the end of our session today. Thank you all for taking out time to watch this live telecast. And for those who missed this live session, can watch the video again in our Facebook. Don't forget to like, comment, and share our Facebook and videos to your friends and colleagues. And please don't forget to join us next week, 18th of August, 2:30 p.m. for the next series of webinar with our guest speaker, Associate Professor Dr. Nurul Muazzah Abdul Latif, the Head of Communication Network System, with the title Communication Network Technology Drivers to Future Sustainability. Alright viewers, as usual, I will end this session with a quote. We do not need a magic to change the world. We carry all the power we need inside ourselves already. We have the power to imagine better. Okay, dolls, keep on dreaming. See you all next week. Stay safe, keep your distance, and stay tuned. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.